There are signals that illuminate the unknown, signals that expand our horizons, and then there are signals that stop the world cold, signals that arrive like a distant siren echoing across the abyss, forcing every scientist who hears them to confront an uncomfortable truth. Our sanctuary in the cosmos is fragile, temporary, and under threat. Voyager 2, the lone survivor pushing deeper into interstellar darkness after nearly 5 decades of relentless travel, has just delivered what may be its final transmission. What came back through the deep space network wasn't the routine trickle of plasma readings or cosmic particle counts the team had grown accustomed to. This one carried urgency. Embedded in the faint carrier wave, traveling 18 long hours across the void, were patterns of escalating cosmic ray intensities, shifting magnetic disturbances, and plasma oscillations that painted a picture far more alarming than any prediction. It came as the probe's power reserves hit critical thresholds, as instruments were being sacrificed one by one to keep the signal alive. It came from a region where the sun's influence fades to nothing and the raw galaxy presses in, and the silence that followed the download said everything. Voyager 2 didn't just report back. It issued a warning for Earth, for our future, for the thin bubble of protection we have taken for granted. Tonight we trace the epic journey from launch to this final cry from the edge, and we confront what this transmission truly means for the world we leave behind. Before understanding the warning, we must return to the machine that delivered it, born from a celestial alignment so precise it occurs once every 176 years. In the mid-1960s, as the space age was still finding its footing, a young researcher tracing orbital paths on paper charts uncovered a gravitational grand tour opportunity. The outer planets were aligning in a rare staircase of slingshot assists that could propel a spacecraft outward with unprecedented efficiency. What might have required separate missions spanning decades could be achieved in a single daring trajectory, leaping from Jupiter to Saturn, then on to Uranus and Neptune. NASA seized the moment and constructed twin explorers designed not merely to visit, but to escape, to become the first human artifacts to venture into the spaces between stars. Voyager 2 launched on August 20th, 1977. A golden armored craft powered by the steady decay of plutonium, carrying computers with less capability than a modern calculator. Its path was set to exploit every gravitational boost, flinging it farther and faster than any previous machine. But that same path also committed it to a one-way plunge into the unknown, where the comforting pressure of the solar wind would eventually yield to the interstellar medium. The alignment that enabled the Grand Tour also positioned Voyager 2 to become our sentinel at the frontier, the one now sending back news that the frontier itself is shifting in dangerous ways. Voyager 2 carved its legend across the outer solar system with a series of encounters that reshaped entire fields of planetary science. At Jupiter, it witnessed colossal storms larger than continents and captured the violent birth of sulfur volcanoes on the Moon. Io, the first active volcanism observed anywhere beyond Earth. Lightning crackled through its atmosphere, while radiation belts nearly crippled the spacecraft's electronics. Yet it survived and pressed on to Saturn, threading a narrow path through icy ring particles traveling at hypervelocity. There it unveiled the complex dynamics of the rings and the thick, hazy atmosphere of Titan, rich with organic chemistry that hinted at prebiotic processes. Then came the ice giants. Uranus revealed itself as a world knocked onto its side by some ancient cataclysm, its magnetic field wildly tilted, its newly discovered rings and moons circling in eerie silence. Finally, Neptune, the windiest planet known, with supersonic gales and the great dark spot, a storm system rivaling Jupiter's. while its moon Triton spewed nitrogen geysers miles into the thin sky. Each flyby returned treasures that filled textbooks and expanded our sense of what worlds could be. But as the cameras powered down to save energy and the last photographs faded into memory, Voyager 2 continued outward. Its true mission was only beginning. The probe was never just about planets. It was built to pierce the boundary and tell us what lies beyond our protective shell. Long after the planetary encounters, after the final image of the pale blue dot captured our world as a mere speck in a sunbeam, Voyager 2 approached the heliopause. Scientists had modeled this boundary as a gradual fade, a soft transition where the solar wind mingled peacefully with interstellar plasma. Reality proved far more violent. On November 5, 2018, the instruments registered an abrupt shift. The flood of solar particles dropped sharply while galactic cosmic rays surged inward with shocking intensity. Plasma density jumped by a factor that stunned the models. The magnetic field lines twisted in unexpected orientations. Unlike the smoother crossing experienced by its twin years earlier, Voyager 2 encountered a sharper, more turbulent interface, almost as if the bubble's edge was being pushed and prodded by external forces. For the first time, humanity sampled the unfiltered interstellar environment directly. And what it revealed was not the serene void of popular imagination. It was a dynamic, pressurized ocean of plasma and particles, colder yet far denser than anticipated, humming with low-frequency waves that propagated through the medium like distant thunder. The heliosphere, our sun's magnificent shield, was suddenly shown to be more like a fragile membrane than an impregnable fortress. And now, years deeper into that realm, the final transmission suggests that membrane may be facing pressures we are only beginning to comprehend. Once beyond the heliopause, Voyager 2 entered a realm where the sun's dominance ends and the galaxy's influence reigns supreme. Expectations of quiet uniformity shattered quickly. The spacecraft began registering a persistent hum, steady plasma oscillations vibrating through the interstellar medium with surprising regularity. Cosmic ray fluxes remained elevated, sometimes spiking in ways that hinted at nearby acceleration sites or structural features in the local cloud. Magnetic fields carried imprints of distant stellar events and perhaps larger galactic flows. Over time, these measurements grew more revealing, painting the very local interstellar medium not as static emptiness, but as a living, flowing river of matter and energy through which our solar system plows at high speed. Then came the period of power management. As the radioactive generators weakened year by year, NASA made the agonizing decisions to deactivate systems. Heaters were switched off, non-essential instruments sacrificed, yet the core sensors persisted, sending back their final reports across the Gulf. In recent cycles, as the cosmic ray subsystem prepared for its own shutdown, the data stream intensified in ways no one predicted. Readings showed not steady state but increasing variability, fluctuations in particle energies, and field strengths that suggested the probe was approaching or sensing a region of transition ahead. The interstellar medium was not uniform. Something was changing. And the final transmission captured that change with chilling clarity. The warning began to crystallize in the engineering and science packets of that last strong signal. Cosmic ray intensities, already far higher than inside the heliosphere, displayed unexpected modulations, brief but significant surges that aligned with shifts in the surrounding plasma density. It was as if invisible fronts or density waves were rolling through the medium, compressing the distant edges of our heliosphere from afar. Models had long suggested that as the solar system orbits the galaxy, it would periodically encounter denser interstellar clouds, events capable of squeezing the protective bubble inward, potentially all the way toward the orbits of the outer planets, or even closer during extreme passages. The data from Voyager 2 now appears to be providing the first direct hints that such a compression phase may lie ahead in the relatively near cosmic future. Magnetic field orientation showed distortions consistent with external pressure building against the heliopause. Plasma wave frequencies drifted in patterns, indicating changing flow velocities or temperatures in the oncoming medium. These were not random glitches from an aging machine. They were coherent signatures of a galactic environment in motion, one that does not care about the fragile bubble we depend upon. The transmission carried the unmistakable signature of a boundary under stress, a shield beginning to feel the weight of the cosmos pressing against it. Even more unsettling were the correlations across multiple instruments in the final packets. The low-energy particle counts and magnetometer readings painted a picture of wake-like disturbances, as though larger-scale structures in the interstellar medium were interacting with the extended heliospheric fields. Cosmic rays, the high-energy messengers from supernovae and other violent galactic events, were penetrating in greater numbers and with energy spectra that challenged existing propagation models. If the heliosphere weakens under external pressure, these particles will reach deeper into the solar system, bombarding planetary atmospheres and surfaces with increased intensity. On Earth, that means heightened risk to satellites, power grids, and aviation from radiation storms. It means potential changes in cloud formation and atmospheric chemistry that could influence climate patterns over centuries. It means subtle but cumulative effects on biological systems across generations. The numbers are stark. The heliosphere normally filters the majority of these galactic cosmic rays, sometimes estimated at 70% or more for the highest energies. A significant compression could slash that protection dramatically. Voyager 2's final transmission isn't speculating about distant possibilities. It is showing us the early signs that such a scenario is not theoretical, but an eventual reality our solar system must face as it sails through its galactic neighborhood. The timing of this revelation could not be more poignant. Voyager 2 is dying. Its power output continues its inexorable decline. One by one, the instruments that have sustained the mission for 48 years are falling silent. The final transmission arrived like a last desperate breath, maximized in clarity and volume, just before major systems were powered down to preserve the spacecraft's ability to point its antenna toward home. Engineers noticed a temporary stabilization in signal strength and data integrity during the download, almost as though the probe gathered every remaining watt to deliver its message intact. What it delivered has forced a complete re-evaluation of our place in the galaxy. The interstellar medium is not a passive backdrop. It is an active participant, capable of reshaping the very environment that allows life to flourish on our pale blue dot. The data reveals that our sun's protective bubble, while vast on human scales, is minuscule and vulnerable against the forces that shape the Milky Way. Regions of higher density gas and dust, remnants of ancient stellar explosions, and the galactic magnetic field itself all exert influence that can distort and compress the heliosphere over time. Previous models underestimated the variability. Voyager 2 has corrected that view with its dying signal. And in doing so, it has handed humanity a warning we cannot afford to ignore. Consider what this means for the world. For the entirety of human history, we have existed inside this invisible shield, shielded from the full fury of galactic radiation. Our technology, our biology, our climate systems have all evolved under its protection. The final transmission suggests that protection is not guaranteed indefinitely. As the solar system continues its journey, perhaps already sensing the leading edges of a denser interstellar flow, the bubble could shrink. Cosmic rays would increase. Atmospheric ionization would rise. The consequences might unfold over decades or centuries rather than tomorrow, but they would be profound. Satellites failing at higher rates, increased cancer risks from elevated background radiation, possible modulation of cloud cover affecting global temperatures. And on longer timescales, the kind of environmental stresses that have coincided with major shifts in Earth's history. This is not doom. It is a call to awareness. Voyager 2 has traveled farther than any other human creation to bring us this knowledge. It has shown us wonders, and now it shows us limits. The warning is clear. We cannot remain passive passengers on this planet forever. The cosmos demands that we become active participants in our survival, that we develop the technologies to shield our world, to venture outward, to understand and perhaps one day influence the forces that shape our heliosphere. The pale blue dot image taken by Voyager 1 remains one of the most humbling views in history, a reminder of our smallness. But Voyager 2's final transmission adds a new layer of urgency to that humility. It tells us that even that smallness exists within a larger system that is itself vulnerable. Our star's bubble is a temporary haven carved out of the interstellar sea. And the sea is restless. The structured patterns in the plasma waves, the rhythmic surges in cosmic ray detections, the subtle but unmistakable shifts in magnetic pressure recorded in the last packets all point toward change. Change that our descendants may have to navigate. Scientists are already modeling scenarios based on this new data, projecting how different interstellar environments, encountered millions or even mere hundreds of thousands of years from now, could reshape the radiation environment throughout the solar system. Some theories suggest past compressions may have played roles in climate shifts or evolutionary pressures on Earth. The transmission doesn't predict immediate catastrophe. It reveals the mechanism by which catastrophe on cosmic scales becomes possible. And in revealing it, it gives us time. Time to prepare. Time to build resilience. Time to reach for the stars not out of curiosity alone, but out of necessity. As the signal from Voyager 2 fades into the background noise of the universe, as its systems power down one final time, the mission team continues poring over every byte of that last transmission. What they are finding only deepens the warning. The interstellar medium ahead shows signs of greater turbulence than behind. Density gradients that could squeeze the heliopause inward. Particle populations that could overwhelm our magnetic defenses. The probe that once danced past Neptune's blue clouds now drifts as a silent witness to forces far greater than itself. It has done its duty. It has explored. It has survived. And in its final moments it has spoken not of triumph alone, but of caution. Humanity stands at a crossroads, illuminated by that distant signal. We can continue as we have, assuming the heavens will always protect us. Or we can listen. Listen to the hum of the plasma, the whisper of cosmic rays, the quiet pressure building against our solar shield. Listen and act. Build better observatories. Design interstellar probes to map the dangers ahead. Develop the technologies that will allow us to live beyond the comfortable confines of our current bubble. The final transmission wasn't an ending. It was an awakening. So now the question echoes in the silence left behind. Will we heed Voyager 2's final warning and rise to meet the challenges of a galaxy that does not forgive complacency? Or will we let this last gift from the edge slip away unheeded? If this transmission from the frontier stirred something deep within you, if it made you feel the vastness and the fragility of our existence, then subscribe now. Because the story of Voyager is our story, and the next chapter depends on what we choose to do with the warning it delivered. Like the video if you believe humanity must look outward to survive. And tell me in the comments, do you see this final transmission as a call to fear, or as the greatest invitation we have ever received to become the kind of civilization capable of thriving among the stars?